Does the Europa Clipper have realistic chances to find traces of life at Jupiter? Can humans stop the Kessler syndrome? How long would Earth survive if it was thrown away from the solar system? And in Q&A Plus, what's the current situation with RTG nuclear fuel? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Wyatt. What are the chances that Europa Clipper detects the presence or possibility of life? Is it even intended for that purpose, or is it more of a mapping and exploration mission? Europa Clipper would have a hard time detecting the presence of life, but it's not impossible. The main purpose of Europa Clipper is that it's going to be doing a bunch of passes by this moon of Jupiter. And it's going to be, as you say, mapping out the surface in sort of higher resolution than has ever been done before. It's also equipped with a lot of other scientific instruments like a magnetometer, like spectrometer. It's going to be able to analyze the composition of the surface on the ice. It's going to be able to measure the interactions of Jupiter's magnetic field with Europa and sort of the environment around Europa. And the most interesting, exciting thing is that it has a ground penetrating radar system. So it's going to be able to send signals that will be able to penetrate down through the ice, bounce off various structures under the ice, and then come back up to the spacecraft. And so that will theoretically allow it to map out the internal structure of Europa. Now, it all depends on the thickness of the ice. You know, if there is a liquid ocean underneath, then it might not be able to reach the ocean, but it might be able to find pockets of water and sort of understand, is it just solid ice? There's no pockets of water underneath, or is it like Swiss cheese? Is it tons and tons of pockets of water? So that's a thing that we don't know. And that's what its main job is going to be. So one of the big uncertainties right now is whether or not Europa has geysers in the same way that Enceladus has geysers. Like, we know that there is water ice spewing out from the south pole of Enceladus into space. And that's ideal because then you just fly through these plumes at Enceladus and you have various instruments on your spacecraft that can detect the presence of various chemicals in those plumes, and then that might give you a sense of whether or not there's the conditions for life. Not necessarily that there's life, but the conditions for life. That would be very useful. While we don't know if there are those plumes on Europa, it's suspected that they might be there. And so if they're there, Europa Clipper will almost certainly find them. And then if it finds them, then it can perform analysis on those plumes. And hopefully you're going to be looking for the kinds of things like hydrogen gas that is suspended in the water, which is essentially food for bacteria. You're looking for organic molecules that are coming out of these plumes with the water as well. That tells you, okay, there's lots of organic material down there in Europa. Like, finding life is going to be so hard. So I don't think that anyone would say, oh yeah, no question. If there's life on Europa, Europa Clipper will find it. Instead, just like we saw with Curiosity and Perseverance, it's this long journey where you're looking for the conditions for life. You're looking for the elements, the chemicals that make up life. And maybe that gets you closer. But I think, to really truly search for life on Europa, we have to get down under the ice. That's going to mean boring down through tens of kilometers of ice to get down to the water beneath and send some kind of submarine in there to look around. Jamin Rooney, do you think going to the moon in one shot instead of this refueling in space is a good idea? So the problem that we had with the Apollo missions, which was going to the moon in one shot, was that we didn't go back. That it was enormously expensive, had sort of no financial reason to do it. It was really just a demonstration of the United States' technology and economy, that it was able to have a human set foot on the moon before the Soviets did. And then they went after other goals. There was no reason to do it. So if we want to be able to go to space, and we want it to be some kind of long-term sustainable, like we stay in space in the way that we stayed on the International Space Station, but now we're on the moon, someone needs to figure out a way to decrease the costs. And building a giant rocket that you completely throw out each time does not really decrease the costs. It's going to still be enormously expensive, and somebody's going to go, boy, we're going to running a deficit again this year. Couldn't we cut that NASA thing? Right? What is having people walk on the moon given us? And people be like, yeah, I guess you're right. And they just vote and then it goes away. So there needs to be a way to be able to bring down the costs, and reusing every part of your rocket makes a ton of sense, theoretically. And we've seen cost decreases from SpaceX using a reusable booster stage, first stage on their rocket, right? They've been able to decrease the launch costs down. You can buy a rocket launch from SpaceX for $60 million when it used to cost you $400 million using an Atlas or a Titan or something like that. So they've been able to decrease the costs. And theoretically, if we get a fully reusable two-stage rocket, then you will have only the costs of the fuel, which is how like an airplane works, right? Like you don't throw out your airplane every time you fly the airplane, you reuse the airplane. You don't throw out your car every time you drive your car, you just refuel your car. And so we should not be throwing out our rocket every time we use it. We should be refueling our rocket. The problem is that getting a rocket into orbit and then being able to bring it back down to Earth and refuel it is at the very limits of engineering, almost the very limits of what the laws of physics permit for a chemical rocket system. It's like just barely possible. And so the amount of actual propellant you're going to be able to carry up into space is going to be less than if you were willing to completely throw away your rocket. But the upside is that you don't have to destroy your rocket. You've landed a rocket and then you fill it up again and it goes back to space. And refueling has a lot of other benefits that, there are a lot of satellites out there in space right now that are essentially have reached the end of their life because they've run out of propellant. They're fully operational. Every part of them works, but because they don't have propellant for station keeping, they have to be shut down and they become space debris. And so if we could refuel satellites, that would be incredible. And so you can imagine, the same concept that works down here on Earth, where you have cars that you refuel, you have refilling stations, gas stations where you refill your car, then you drive to another one, you refill. That concept, that paradigm would work for space exploration, that you would have a place in low Earth orbit that you can refuel a spacecraft, use every drop of fuel to get into orbit, and then you hit the refueling station, you refuel your rocket, and then you head off to another destination, you refuel your rocket, head off to another destination. Like that model should make space exploration a more sustainable, less expensive, more, repeatable system. It's just that technology is all brand new. That although some tests have been done refueling in space, NASA has an experiment on board the International Space Station where they've tested out refueling in space. Nobody has tested at the kind of scale that would be necessary for sending missions to the moon, that you would need to be storing cold propellant in the vacuum of space. And hydrogen specifically is a very difficult gas to store. Very small molecules. They really want to escape. That you need some way to make sure that you're keeping your fuel at the right temperature in space, which is actually really tricky to do. And so there's like a lot of technical challenges. And so far, the ship that is expected to become the tanker that's going to carry the fuel into space has not demonstrated that it has the reusability, or we don't know if Starship is going to work. So, I think that the idea that you're going to refuel in space is inevitable, that it is obviously the right idea because you don't have to destroy your rocket, right? But it is a technical challenge. And I think that there's unfortunately, there's too much riding on Starship being successful as quickly as possible. It's almost time for the Artemis 2 mission to launch. And then comes Artemis 3. And it's supposed to use Starship as its landing system, but Starship still has not demonstrated that it can be the landing system, and hasn't demonstrated in-orbit refueling. There's like a big to-do list that we're waiting on. But that doesn't mean that these technologies shouldn't be worked out. They should absolutely be worked out. People should work on them. Just, it's going to take more time. So if you want to once again demonstrate the economic and scientific might of the United States, they should go with a disposable rocket, boots on the ground, return them safely back to Earth, demonstrate that they can do it. They still got it. But if you want like a long-term sustainable system, then you have to invest in all of these technologies and sub-technologies. It's time to shout out all the new $5 patrons and above. George P. Burdell, Juanjo Gonzalez, Gary Huseman, Mark, Juan Madrigal, Paula's Planet PLW, Tiffany Rogers, Rufus Reynolds, Rylan Fellner, and Roshan Bukhari. Join the club at patreon.com/universe today. DS8197, do you think that we as a species will stop the Kessler syndrome? Kessler syndrome, this is the idea that eventually there'll be so much space debris that it's going to collide with each other and into smaller and smaller pieces, and they'll just become impossible to send new spacecraft into space. And that is not a really accurate sort of understanding of what's going to happen with sort of the future of space junk. That, the space junk that is close to the Earth deorbits relatively quickly. And so even if you had a Kessler syndrome close to the Earth, that material would re-enter the Earth's atmosphere within a couple of years, within a decade, and clean it all back up again. It's the stuff that's higher, the stuff that's say 1,000 kilometers altitude, that can last longer, can last a few decades. The stuff that's even higher than that can last centuries. That's stuff you have to be worried about. But then that stuff is also in a much larger volume or much larger surface area where all of that material is. And so you're not going to get the sort of common collisions, and that you will always be able to pass through the region. If you're trying to operate a satellite in that area, then you're going to have to maneuver more often. There's a higher likelihood that you're going to take damage on your spacecraft. So there won't be this kind of tipping point that everything just suddenly gets destroyed. It's just that if you try to operate a satellite in one of these orbits that has got a lot of space debris and there's a lot of impacts, or there's a lot of material there, you're going to either have to expend a lot of propellant avoiding potential collisions, or you're going to have to accept a higher risk that your satellite is going to become part of the problem. That's going to get hit by debris, torn apart, and it's going to become a bigger problem. But if you just want to like zip out into space, that will always be relatively safe. It would have to be really unlucky for your spaceship to be trying to slip through the sort of debris spheres and get hit. Jonathan Chamberlain, if Earth somehow left the sun's gravitational influence and we became a rogue planet, how long would humans last, or could we survive? We wouldn't last long if the average temperatures on Earth decreased by just a few degrees. The Earth would enter an ice age. So, if the Earth was flung off into space, then the Earth would immediately enter an ice age. And then all life would die on the surface. Now, maybe there'd be some people who were living in deep underground and they would be harnessing the Earth's internal heat. And that lets you survive for longer. It would take probably billions of years for the Earth to cool down to the point that you wouldn't be able to harness the internal heat longer. Actually, there's still radioactive decay going on inside the Earth that's helping to contribute to its internal temperature. It'd still take a long time to cool down. But if you try to live on the surface, it would be very, very, very cold. On Pluto, they have glaciers made of nitrogen, right? The stuff that's gas in our atmosphere on Pluto moves around on the surface. On Titan, it rains methane. A thing that is gas here is rain on Titan. So yeah, it can get very cold. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A+. In this week's bonus question, what is the current situation with the RTG nuclear fuel? I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. We do the live show every Monday at different times, depending on which part of the planet Earth we are trying to be in the early evening for. Now, the next one is going to be focused on European time. So it's going to be on Monday, January 19th at 8 a.m. Pacific time, which ends up being evening for the UK and Europe. And I don't know what time it is for people in Australia. But anyway, that's when we're going to be doing the next episode. Now, I'm going to chat about my sort of history with video games. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, Dark Finger, David Gilton, David Matz, Evan Pro, Craig Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nord Space, OneStepForAnimals.org, Parlbach, Renkaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldemore Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I have been giving you a history of my various interests in previous episodes. So we talked about my interest in anime and how that rose, and my interest in role-playing games and how that came about. And so I want to talk about video games because I've been playing video games longer than most of you have been alive. So I am 54 years old. And the first time I ever saw a video game, I think I was 5 or 6 years old. And I was on BC ferries going from Vancouver Island to Vancouver. And there was a Pong game in the ferry. And I was just dumbstruck watching people play this game. And then over time, better and better video games were put into the BC ferries. And I spent a lot of money playing video games while I was growing up. You know, you put money into machines to play video games. I know it's super bizarre for the kids these days. But of course, that quickly stretched out into me playing video games on various computers. The very first computer that I got access to was probably a Commodore 64. A friend of mine had an Atari we were able to play on, but we were able to actually like buy games in the store and run them on floppy disks on the Commodore 64. And then we were able to start like programming and trying to learn to make our own games, which was pretty cool. And then I've owned all manner of machines. And I would say the sort of things changed around the year 2000 with the birth of my eldest child. And my wife and I at the time bought Xbox 360 and then bought a whole bunch of games for it. And gaming became a big part of raising my children. My wife and I played a ton of games, and my kids love to play games from an early age, and they still do. And then when my kids were around 10 or so, we started to play Minecraft, which was getting big at the time. And I ran a Minecraft server inside the house, and the kids were able to play. And then we actually went to the first Minecon. I took my kids to the first Minecon that we could actually meet Notch and learn about the game, which was pretty cool. And then obviously properly transitioned my kids to be PC gamers and not Xbox. And we never owned a PlayStation. We sort of I taught my kids how to build their own PCs. And so they both had PCs with handles on them so that they could take their PCs to their friend's place and be able to hook them up to TVs, and they could do LAN gaming and stuff at their friends' places. So I play a lot of video games. A lot of the games that I like are like space-based games, obviously. And I think about some of the most influential are probably Master of Orion, and specifically Master of Orion 2. Like, I was around 20 or so when that game came out, and I threw a lot of time at Master of Orion. Civilization, and I really enjoyed the first XCOM series. And those really defined my taste in video games. The sort of 4X, Expand, Explorer, I forget what all the X's stand for. But, a space game where you're trying to conquer the universe. That was my jam, as well as or strategy games where you're trying to conquer the ground, and then XCOM, where it's like these very tactical simulations where you're playing these games where you're sort of fighting against an alien invasion. But I love the sort of the style, and so now I play a ton of games. Mostly right now I'm playing Path of Exile 2, Project Zomboid, Stellaris. I've definitely fallen into these sort of Vampire Survivors like games, Brotato, and then a lot of other strategy games as well. And card games, I really like Slay the Spire. So a big chunk of my life is spent playing video games, and I wouldn't have it any other way. So if your kid's there and your parents don't think that you should be playing video games, tell them wrong. Tell them your space dad says it's totally fine. It's good for you. All right. We'll see you next time.